Okay, as promised, we are going to add a debug that allows us to see things on screen and run this in slow-mo so we can see the details of our animation. So, first thing we're going to need is a big global called debug mode. We initialize it as false, but whenever we want to put our thing into debug, we turn this to on. Okay, then if we're going to be going in slow-mo, we need a frame skip. So debug frame skip, we started off at 30, so a half a second basically. And then we need the actual debug timer, which we set to the same value to start with. Okay. Then we need a debug function. Maybe here. Function. Maybe let's call this is debug or do debug. Do debug because it does something and we don't want to call it accidentally. Okay, for now we're just going to return false. So what this is going to do is in our TIC function we check for inputs because we don't want our thing to ever freeze. And then we go if do debug, then if not do debug. If we're not in debug, then we run as normal. Else we just skip it and we don't render this frame. So for now, nothing should change because do debug will always return false. Actually, do debug can just return debug mode, but it doesn't matter. Okay, return false. So that's not going to do anything. See, it just runs as normal. Okay. But what we do want to do in do debug is if we press a specific key, we should go into debug mode. Now, I'm old school, so from Quake 3 Arena or other old games, I think Half-Life had it as well, the grave, the little backtick on the tilde key, used to open the console. So, what's that button? Help keys. Help keys. It's called a grave 44. Okay, so if key press, because we're looking specifically for a keyboard input 44, then debug mode is equal to not debug mode. We just switch its state and then return false. So run it, and then while it's running, we're just going to hit tilde cup, the button. Oh, it's not going to do anything. So maybe let's make it do something. Have I explained trace? It's basically like a print command, but it prints to the console, to this thing. So it allows us to see values while the program is running. Trace debug. And then we probably want to concatenate to this what the debug mode is switching to. Okay, this isn't going to work because that's a boolean, so we need to toString that boolean so that it becomes the text word true or false as opposed to an actual binary value. So what this will do is not affect our program at all, but it'll print to the console debug true or debug false depending on how many times we press a button. So run it, hit the grave, hit it again, and now we look at the console and we have debug true for a while, debug false, and if we had debug outputs they would have been printing in between these. So as an example, maybe every time our snake head moves we do all these calculations, that's the direction, and then we change where snakehead goes. So in here we go debug trace. I'm going to write that function now, don't worry. Debug trace, and the text is going to be snakehead, and then add to it snakehead dot x position, followed by a comma, followed by snakehead dot y position. Just output the snakehead x and y position to the console. Now we're going to need this debug trace function. So right here, function debug trace, it's just going to take text. But then instead of just doing a trace, we're going to go if debug mode is on, then trace text. And in other words, it will only print the trace if debug mode is on. Let's test it. Run the thing, and then while I'm busy playing the thing, turn on debug, and then turn off debug. And now we go look at the console. You scroll all the way up, there's the first one. Debug went to true, then it started printing the location of the snake head until debug went to false, and then it stopped. Cool. But now we need to get that slow-mo thing going. So let's go back to debug, do debug. And then instead of just returning false, return false is going to be our default, but instead of returning false, if we are actually in debug mode, we need to do stuff. Then end. This is very similar to how we use our normal t timer. It's going to be debug t is equal to debug t minus 1. If debug t is equal to 0, then we do actually want to run a single frame. We'll run update and draw once. So first reset the value to debug frame skip, so we're ready for the next one, and then return false just this one time. Otherwise, if debug t is not equal to 0, then return true, which means it's going to tell TIC that do debug is true, meaning it should not run these two functions, effectively creating a frame skip for as long as that is. I think that's it. Let's see what it does. Run it. It even works. Look at that. Now it's in slow-mo, and if I turn debug off, it goes back to normal speed. But now we can see frame by frame what that animation is doing. See, like I was saying in previous episodes, the position of the snakehead is actually already in place, but then we animate it from its previous location up to there to make it look like it's moving smoothly. Maybe we should put something on screen that says we're in debug, even though... Let's add a debug draw. So below draw, in here we can print any information to screen when it's in debug. So let's just print the word debug in the top left corner in white, so that we, okay, and then debug draw needs to be called somewhere. So in TIC is our main flow, right? Boot TIC. So after our usual draw, that's if not debug, but I do actually want to, if debug mode is true, then okay, which means now if it goes to debug mode, it says debug up there, so we know why it's running super slow. Later on we can even put the grid in debug, so we don't have to look at it the whole time. Okay, now about the segments. It would be in move. So at the moment all we're moving is the snakehead, and I think we should still do that last, because if you look at the length of the snake, I'm just going to run this. Okay, so these are supposed to process that way. The way this one knows where it's supposed to go is where the one in front of it used to be. Same for this one, same for this one. So if we set the values from the first one down, we're effectively wiping out what we need before we need it. So we actually have to start at the bottom. So, and then move the snakehead last. So for I equals starting with the last entry of snake, going down to 2, you'll understand why in a second, going negative, so we start at, in this case, what, 4, then 3, and then 2. And in each of those cases, we need two things. We need the actual segment, which is going to be snake index I, but we also need a reference to the one in front of it. So call it seg ahead is equal to snake underscore I minus 1, which means when we get to 2, snake minus I minus 1 would be 1, and then we don't want to go again because there is no snake ahead at snake 0, because we start counting at 1. Then what do we need to do? The segment's x direction, let's do x position first, is going to be seg ahead dot x position, and then the current segment y position is going to be the one that's ahead of its y position. Okay, that should make them move. Cool, they move. But now things are going to get weird when we start animating these. It is sometimes... Just look at this in slow-mo. Yep, the whole snake is moving. I know it looks like the head is in the middle, but eventually we're going to be animating all the snake segments that way. And then it won't look as jarring. Okay. And then put in some comments so we know what we're doing. We need to get the segments to animate. We're going to need those X and Y directions. Now the direction is going to be a product of where the one in front of it is. So seg dot, oh wait, we need to do this before we change its position because we need its position to calculate it. X direction is going to be the difference between the one ahead of it and it. So snake ahead dot x position minus seg dot x position, and then the y direction is going to be the same, but for y. Okay, so when we decide to move the snake, we start at the tail end. We grab the last segment of the tail and the one ahead of it. Then we figure out in which direction that segment, seg, needs to move to get to the space that we're about to set it to. And then we set it to it. Which means when we draw the snake, let's go to draw. When we draw the snake body, we can do it the same way we do it with this. So we can go rectangle minus underscore v dot x direction times t, and the same thing but for y. What did I break? In draw function, attempt to call a number value. Oh, we're missing the minus. Run. Still? Attempt to perform arithmetic function on a null value x direction. Why does it not have an x direction? sec.x_dir, sec.y_dir. Oh, because move has to happen as the program runs the first time, otherwise we're not going to have it. So we actually need to do our timer tick first. So we need to have move execute on the first loop. So we're going to update t last and then start it with a t value of 0. Where's t? There's t. Instead of cell size, we start at 0. Here we go. Hey, look, it's animating. Look, even in slow-mo, you can see it's animating. And now you also see that the snake head is in the correct spot because everything's moving together now. But now here's a funny thing. If I turn, the square leaves a gap in between. So I want to see if we can... I want to draw the snake's body with circles instead of squares. But then what we could do, let's give it a second to turn, is we can put the circles in there and just move the tail and keep the head back. Like draw less circles for the tail as it moves and draw more circles for the head as it moves. Because the middle bit doesn't need to animate. That's the idea anyway. Because then when we turn like this, the snake will actually fall into that corner. But to do that, I'm going to have to write some test code and make sure how to make it work before I can, be seen in public doing so. So that's going to have to be in the next one.